The Virginia-class, also known as the SSN 774 class, is a class of nuclear-powered fast attack submarines in service with the United States Navy. The submarines are designed for a broad spectrum of open ocean and littoral missions. They were conceived as a less expensive alternative to the Seawolf-class attack submarines, designed during the Cold War era, and they are planned to replace the older of the Los Angeles-class submarines, 21 of which have already been decommissioned. The class was developed under the codename Centurion, renamed to NSSN later on. The Centurion Study was initiated in February 1991. Virginia-class submarines will be acquired through 2043, and are expected to remain in service past 2060. Based on recent updates to the designs, some of the Virginia-class subs will still be in service in 2070. Innovations: the Virginia-class incorporates several innovations not previously incorporated into other submarine classes. Photonics masts: instead of a traditional periscope, the class utilizes a pair of ANBVS-1 telescoping photonics masts located outside the pressure hull. Each mast contains high-resolution cameras, along with light intensification and infrared sensors, an infrared laser rangefinder, and an integrated electronic support measures array. Signals from the mast sensors are transmitted through fiber optic data lines through signal processors to the control center. Visual feeds from the masts are displayed on LCD interfaces in the command center. Propulsor: in contrast to a traditional bladed propeller, the Virginia-class uses pump-jet propulsors, originally developed for the Royal Navy's Swiftsure-class submarines. The propulsor significantly reduces the risks of cavitation, and allows quieter operation. Improved sonar systems: sonar arrays aboard Virginia-class submarines have an open system architecture which enables rapid insertion of new hardware and software as they become available. Hardware updates are usually carried out every 4 years while software updates are carried out every 2 years. Virginia-class submarines feature several types of sonar arrays. BQQ-10 bow-mounted spherical active-passive sonar array, a wide-aperture lightweight fiber optic sonar array, 2 high-frequency active sonars mounted in the sail and bow. The chin-mounted and sail-mounted high-frequency sonars supplement the main sonar array, enabling safer operations in coastal waters, enhancing under-ice navigation as well as improving ASW performance. Low-cost conformal array high-frequency sonar, mounted on both sides of the submarine's sail, provides coverage above and behind the submarine. Virginia-class submarines are also equipped with a low-frequency towed sonar array and a high-frequency towed sonar array. TB-16 or TB-34 Fatline Tactical Towed Sonar Array, TB-29 or TB-33 Thin Line Long-Range Search Towed Sonar Array, other improved equipment. Fiber optic fly-by-wire ship control system replaces electro-hydraulic systems for control surface actuation. Command and control system module built by Lockheed Martin. Modernized version of the ANBSY-1 integrated combat system designated ANBYG-1 and built by General Dynamics AIS. And BYG-1 integrates the submarine tactical control system and weapon control system. The USA California was the first Virginia-class submarine with the advanced electromagnetic signature reduction system built into it, but this system is being retrofitted into the other submarines of the class. Integral 9-man lockout chamber. Rescue equipment: SEIEMK-11 suit, S, enable ascent from a sunken submarine, lithium hydroxide canisters which remove carbon dioxide from the submarine's atmosphere, submarine emergency position indicating radio beacon. History: Virginia-class submarines were the first U.S. Navy warships designed with the help of computer-aided design and visualization technology. Around 9 million work hours are required for the completion of a single Virginia-class submarine. Over 4,000 suppliers are involved in the construction of the Virginia-class. Each submarine is projected to make 14 to 15 deployments during its 33-year service life. The Virginia-class was intended, in part, as a cheaper alternative to the Seawolf-class submarines, whose production run was stopped after just 3 boats had been completed. To reduce costs, The Virginia-class submarines use many commercial off-the-shelf components, especially in their computers and data networks. In practice, they actually cost less than $1.8 billion each, due to improvements in shipbuilding technology. In hearings before both House of Representatives and Senate committees, the Congressional Research Service and expert witnesses testified that the current procurement plans of the Virginia-class are €1 per year at present, accelerating to 2 per year beginning in 2012 would result in high unit costs and an insufficient number of attack submarines. In a March 10, 2005 statement to the House Armed Services Committee, Ronald Irk of the CRS testified that, assuming the production rate remains as planned, production economies of scale for submarines would continue to remain limited or poor. In 2001, Newport News Shipbuilding and General Dynamics Electric Boat Company built a quarter-scale version of a Virginia-class submarine dubbed Large-Scale Vehicle 2 Cutthroat. The vehicle was designed as an affordable test platform for new technologies. The Virginia-class is built through an industrial arrangement designed to keep both GD Electric Boat and Newport News Shipbuilding and Dry Dock Company in the submarine building business. Under the present arrangement, the Newport News facility builds the stern, habitability and machinery spaces, torpedo room, sail and bow, while Electric Boat builds the engine room and control room. The facilities alternate work on the reactor plant as well as the final assembly, test, outfit and delivery. Unregistered trademark Rorke wrote in 2004 that, compared to a one-yard strategy, approaches involving 2 yards may be more expensive but offer potential offsetting benefits. Among the claims of offsetting benefits that Irk attributes to supporters of a two-facility construction arrangement is that it would permit the United States to continue building submarines at 1 yard even if the other yard is rendered incapable of building submarines permanently or for a sustained period of time by a catastrophic event of some kind, including an enemy attack. In order to get the submarine's price down to $2 billion per submarine in FY $5, the Navy instituted a cost reduction program to shave off approximately $400 million in costs off each submarine's price tag. The project was dubbed 2 for 4 in 12, referring to the Navy's desire to buy 2 boats for $4 billion in FY 12. Under pressure from Congress, the Navy opted to start buying 2 boats a year earlier, in FY 11, meaning that officials would not be able to get the $2 billion price tag before the service started buying 2 submarines per year. However, Program Manager Dave Johnson said at a conference on March 19, 2008, that the program was only $30 a million away from achieving the $2 billion price goal, and would reach that target on schedule. The Virginia-class program office received the David Packard Excellence in Acquisition Award in 1996, 1998, 2008, for excelling in 4 specific award criteria: reducing life cycle costs, making the acquisition system more efficient, responsive, and timely, integrating defense with the commercial base and practices, and promoting continuous improvement of the acquisition process. In December 2008, the Navy signed a $14 billion contract with General Dynamics and Northrop Grumman to supply 8 submarines. The contractors will deliver 1 submarine in each of fiscal 2009 and 2010, and 2 submarines on each of fiscal 2011, 2012 and 2013. This contract will bring the Navy's Virginia-class fleet to 18 submarines. And in December 2010, the United States Congress passed a defense authorization bill that expanded production to 2 subs per year. 2 submarine per year production resumed on September 2, 2011 with commencement of SSN 787 construction. On June 21, 2008, the Navy christened New Hampshire, SSN 778, the first Block II submarine. This boat was delivered 8 months ahead of schedule and $54 a million under budget. Block II boats are built in 4 sections, compared to the 10 sections of the Block I boats. This enables a cost saving of about $300 million per boat, reducing the overall cost to $2 billion per boat and the construction of 2 new boats per year. Beginning in 2010, new submarines of this class will include a software system that can monitor and reduce their electromagnetic signatures when needed. The first full-duration 6-month deployment was successfully carried out from October 15, 2009 to April 13, 2010. Authorization of full-rate production and the declaration of full operational capability was achieved 5 months later. In September 2010, it was found that urethane tiles, applied to the hull to damp internal sound and absorb rather than reflect sonar pulses, were falling off while the subs were at sea. Admiral Kevin McCoy announced that the problems with the mold-in-place special hull treatment for the early subs had been fixed in 2011, then the Minnesota was built and found to have the same problem. Professor Ross Babbage of the Australian National University has called on Australia to buy or lease a dozen Virginia-class submarines from the United States, rather than locally build 12 replacements for its Collins-class submarines. In 2013, just as 2 per year sub construction was supposed to commence, Congress failed to resolve the United States fiscal cliff, forcing the Navy to attempt to deobligate construction funds. Technology barriers. Because of the low rate of Virginia production, the Navy entered into a program with DARPA to overcome technology barriers to lower the cost of attack submarines so that more could be built, to maintain the size of the fleet. These include propulsion concepts not constrained by a centerline shaft, externally stowed and launched weapons, conformal alternatives to the existing spherical sonar array, technologies that eliminate or substantially simplify existing submarine hull, mechanical and electrical systems, automation to reduce crew workload for standard tasks. Virginia Payload Module. The Block 3 submarines have 2 multi-purpose Virginia payload tubes replacing the dozen single-purpose cruise missile launch tubes. The Block V submarines built from 2019 onward will have an additional Virginia Payload Module mid-body section, increasing their overall length. The VPM will add 4 more VPTs of the same diameter and greater height, located on the centerline, carrying up to 7 Tomahawk missiles apiece. That would replace some of the capabilities lost when the SSGN conversion Ohio-class submarines are retired from the fleet. Initially 8 payload tube silos were planned, but this was later rejected in favor of 4 tubes installed in a 70-foot-long module between the operations compartment and the propulsion spaces. The VPM could potentially carry medium-range ballistic missiles. Adding the VPM would increase the cost of each submarine by $500 million. This additional cost would be offset by reducing the total submarine force by 4 ships. More recent reports state that as a cost reduction measure the VPM would carry only Tomahawk SLCM and possibly unmanned undersea vehicles, with the new price tag now estimated at $360 a euro $380 million per boat. The VPM launch tube silos will reportedly be similar in design to the ones planned for the Ohio-class replacement. As of September 2013, the CNO was still hoping to field the VPM from 2027, but deployment now seems unlikely since JROC moved the program in February 2013 from the prompt strike budget to the main Navy shipbuilding account, which is already under financial pressure. Specifications. Builders, GD Electric Boat and HII Newport News. Length, 377 ft, beam, 34 ft. Displacement, 7,800 long tons, payload, 40 weapons, special operations forces, unmanned undersea vehicles, advanced seal delivery system, propulsion, the S9G nuclear reactor, 29.8 MW delivering 40,000 shaft horsepower. Nuclear core life estimated at 33 years. Maximum diving depth, greater than 800 ft. Allegedly around 1,600 feet, speed, greater than 25 knots, allegedly up to 34 knots, planned cost, about $1.65 billion each, actual cost, $1.5 billion, $2.6 billion, crew, 120 enlisted and 14 officers, armament, 12 VLS and 4 torpedo tubes, capable of launching Mark 48 torpedoes. UGM-109 tactical Tomahawks, Harpoon missiles and the new advanced mobile mine when it becomes available. Decoys, acoustic device countermeasure Mk3/4, boats, Block I, modular construction techniques were incorporated during construction. Earlier submarines were built by assembling the pressure hull and then installing the equipment via cavities in the pressure hull. This required extensive construction activities within the narrow confines of the pressure hull, which was time-consuming and dangerous. Modular construction was implemented in an effort to overcome these problems and make the construction process more efficient. Modular construction techniques incorporated during construction include constructing large segments of equipment outside the hull. These segments are then inserted into a hull section. The integrated raft and hull section form a module which, when joined with other modules, forms a Virginia-class submarine. Block I boats were built in 10 modules, with each submarine requiring roughly 7 years to build. USA Virginia, SSN 774, commissioned and in service. USA Texasa, SSN 775, commissioned and in service. USA Hawaii, SSN 776, commissioned and in service. USA North Carolina, SSN 777, commissioned and in service. Block II boats were built in 4 sections rather than 10 sections, saving about $300 million per boat. Block II boats were also built under a multi-year procurement agreement as opposed to a block-buy contract in Block I, enabling savings in the range of $400 million. As a result of improvements in the construction process, New Hampshire was $500 million cheaper, required 3.7 million fewer labor hours to build, thus shortening the construction period by 15 months compared to USS Virginia. USA New Hampshire, SSN 778, commissioned and in service. USA New Mexico, SSN 779, commissioned and in service. USA Missouri, SSN 780, commissioned and in service. USA California, SSN 781, commissioned and in service. USA Mississippi, SSN 782, commissioned and in service. USA Minnesota, SSN 783, commissioned and in service. Block III, SSN 784 through approximately SSN 791 are planned to make up the third block or flight, and began construction in 2009. Block III subs will feature a revised bow with a large aperture bow sonar array, as well as technology from Ohio-class SSGNs. The horseshoe-shaped lab sonar array will replace the spherical main sonar array, which has been used on all U.S. Navy SSN since 1960. The lab sonar array is water-backed as opposed to earlier sonar arrays which were air-backed and consists of a passive array and a medium-frequency active array. Compared to earlier Virginia-class submarines, about 40% of the bow has been redesigned. North Dakota, SSN 784, named July 15, 2008, laid down May 11, 2012, was christened on November 2, 2013 and is scheduled to be commissioned in October 25, 2014. John Warner, SSN 785, named January 8, 2009, laid down March 16, 2013, and is contracted for delivery in August 2015. Illinois, SSN 786, construction began in March 2011. It is contracted for delivery in August 2016. Washington, SSN 787, named April 13, 2012, construction began on September 2, 2011. Colorado, SSN 788, named June 25, 2012, and under construction with commissioning expected in late 2016/early 2017. Indiana, SSN 789, South Dakota, SSN 790, Delaware, SSN 791, Block 4, the most costly shipbuilding contract in history, was awarded on April 28, 2014 as prime contractor. General Dynamic Electric Boat took on a $17.6 billion contract for 10 Block 4 Virginia-class attack submarines. The main improvement over the Block 3 is the reduction of major maintenance periods from 4 to 3, increasing each ship's total lifetime deployments by 1. The long lead time materials contract for SSN 792 was awarded on April 17, 2012, with SSN 793 and SSN 794 following on December 28, 2012. The U.S. Navy has awarded General Dynamics Electric Boat a $208.6 million contract modification for the second fiscal year 14 Virginia-class submarine, SSN 793, and two FY-15 submarines, SSN 794 and SSN 795. With this modification, the overall contract is worth $595 million. Block 4 will consist of 9 to 10 submarines. Based on the planned split between Block 4 and Block V boats, the Block 4 procurement should comprise the following hull numbers. On September 18, 2014, the Secretary of the Navy, Ray Mabus, announced that SSN 792 would be named USS Vermont. Block V subs may incorporate the Virginia Payload Module, which would give guided missile capability when the SSGNs are retired from service. The Block V subs are expected to triple the capacity of shore targets for each boat. Future acquisitions: the Navy plans to acquire at least 30 Virginia-class submarines. However, more recent data provided by the Naval Submarine League and the Congressional Budget Office seems to imply that more than 30 may eventually be built. The Naval Submarine League believes that up to 10 Block V boats will be built. The same source also states that 10 additional submarines could be built after Block V submarines, with 5 in the so-called Block 6 and 5 in Block 7, largely due to the delays experienced with the improved Virginia. These 20 submarines would carry VPM, bringing the total number of Virginia-class submarines to 48. The CBO in its 2012 report states that 33 Virginia-class submarines will be procured in the 2013 to 2032 timeframe, resulting in 49 submarines in total, since 16 were already procured by the end of 2012. Such a long production run seems unlikely, but it should be noted that another naval program, the Arleigh Burke-class destroyer, is still ongoing even though the first vessel was procured in 1985. However, other sources believe that production will end with Block V. In addition, data provided in CBO reports tends to vary considerably compared to earlier editions. In 2013, execution of a 10-submarine contract was put in doubt by budget sequestration in 2013. On April 28, 2014, the Navy awarded a $17.6 billion order for 2 subs to be built during each of the next 5 years. Improved Virginia, initially dubbed Future Attack Submarine. Improved Virginia-class submarines will be an evolved version of the Virginia-class. It was planned that the first improved Virginia-class submarine would be procured in 2025. However, according to some reports, their introduction has been pushed back by 8 years, to 2033. See also: 095-class submarine, the latest for China's People's Liberation Army Navy, first launched in 2010, Astute-class submarine, the latest in service with the British Navy since 2010, Barracuda-class submarine, the latest for the French Navy, with the first to be launched in 2016, Yasen-class submarine, the latest for the Russian Navy, first launched in 2010. References. Further reading: Clancy, Tom. Submarine, A Guided Tour Inside a Nuclear Warship. New Yorker Berkeley Books, 2002. ISBN 0-425-18300-90 CLCA 48749330. Chrysalie, J.L. United States Naval Submarine Force Information Book. Marblehead, More Graphic Enterprises of Marblehead, 2000. OCLCA 53364278, Chrysalie, Jim. U.S. Nuclear Submarines, The Fast Attack. Oxford, UK, 2007. ISBN 1-846-03168-0 OCLCA 141383046. Cross, Wilbur and George W. Fries. Encyclopedia of American Submarines. New Yorker Facts on File, 2003. ISBN 0-816-04460-0 OCLCA 48131805, Gresham, John and Westwell, Ian. Sea Power. Edison, New Jersey. Chartwell Books, 2004. ISBN 0-785-81792-10 CLCA 56578494. Parker, John. The World Encyclopedia of Submarines. London Lawrence, 2007. ISBN 0-754-81707-50 CLCA 75713655. Palmer, Norman. The Naval Institute Guide to the Ships and Aircraft of the U.S. Fleet. Annapolis, Maryland Naval Institute Press, 2001. ISBN 1-557-50656-60 CLCA 47105698. United States. The Virginia-class submarine program. Fort Belvoir, Virginia, Defense Standardization Program Office, 2007. OCLCA 427536804, external links. Holian, Thomas. Voices from Virginia. Undersea Warfare Magazine 9 Early Impressions from a First-in-Class, Johnson, Dave, CAPT. Muniz, Dustin, LTJG. More for Less. Undersea Warfare 9 of the Navy. Euro unregistered trademark S plan to reduce costs on Virginia-class submarines while increasing production, Little, Molly. The Elements of Virginia. Undersea Warfare Magazine and updates on the boats of the Virginia-class, Little, Molly. A snapshot of the Virginia-class with Rear Admiral Dave Johnson. Undersea Warfare Q&A on the Virginia-class program since the winter 2007 article, Naval History and Heritage Command, Virginia-class attack submarine, SSN, NSSN Virginia-class attack submarine, United States of America, stealth, endurance, and agility under the sea, Virginia-class submarines. Some U.S. Navy photos of Virginia-class submarines.